Hey everyone, good to be here. I'm going to blast through this pretty quickly. Most of the slides are pretty basic. How many people here are in data science? Show of hands. Quite a few. How many here know Python? How many here are just here for the beer? Okay, I thought as much. All right, so what is neural search and why should I give a damn? Cute and not so cute animals ahead, fair warning. I'm Alex, developer relations lead at Jina. Developer relations, basically the engineers do all the hard work. We make it look sexy to the community. We're open source. We want loads of people all around the world to use our stuff. That's part of my job. I really love open source, usually in Berlin. I'm on Twitter, I'm on GitHub. Like I said, blasting through it quick. So take photos because this ain't going to last long. We're going to go over the basics of what neural search is, how it works. Probably won't show you any code because we ain't got time. Jina is a startup in Berlin. We love open source. If you're in data science, you've heard of BERT as a service, Fashion MNIST. We're started by that guy. All those lovely grainy black and white photos of fashion you never knew you wanted. The good stuff's at get.jina.ai, business stuff at jina.ai. We make loads of stuff. Yeah, skipping that, don't have time. What the flip is neural search? So before we ask what the flip is neural search, well, what the flip is search to begin with, because most people, when we think of search, what do we think of? A boring white little box. You type things, smack enter, pages and pages of results come back. Google, Amazon, Stack Overflow, all of these sites. You all know what search is. But what's neural search? So, oh, my animated GIFs don't work. Oh, I knew it. Sorry, everyone, it'll be a disaster now. We don't have animation. So neural search is basically that kind of search plus neural networks. So, oh, and my hidden slides aren't being hidden. Oh my God, what secrets will be revealed here tonight, people? So one example might be, instead of searching text, you want to search images. You want to run Zalando into the ground and be the next Zalando. You want people to be able to take pictures of their shoes, upload them, and find similar pictures of shoes so they can go out there and impress potential mates. And that's an example of neural search. It's upload a thing, find similar things. We've got an example that, thank God, is finally up and running again, because curse you, Jeff Bezos and AWS. There's a QR code there for if you're masochistic and want to run it on your phone, you can. And this is actually built with Streamlit, because it is cool. Also, chatbots are a kind of search when you think about it. You type in a query, instead of getting pages of results back, you just get one result back. Then you type in another query, and, you know, rinse and repeat. And we've got another example of that as well. Again, thank God. Everything, all the examples fell down today. That was fun. Or you could upload a PDF and find similar PDFs from your machine learning library, because that's a thing everyone loves. We don't have an example for that yet. I'm working on it. I'm not one of the cool engineers. I don't understand how to do that bit yet. Or, you know, you could build the next Shazam. You could upload a Beyonce song and find songs from Destiny's Child, because they're quite similar. Or videos. So in short, it's similarity search. This really doesn't work without animation. You'll have to come to one of my other talks when these will work. So how does it work? So the technical stuff is it uses deep learning models to create and compare embeddings to find similar things. We're going to look at that from how we do it ourselves. And it's animal time. So first of all, let's look at some pictures. See, everyone's smiling now. Okay, some of you are only smiling on the inside, but I'm imagining you all are. So what have they got in common? They're cute, fluffy, yes. Thank you. It took long enough. You've all had a few beers and you're very slow. So we can put them on a graph, because there's only one real difference. Are they a cat or are they a dog? So we've got cattiness, we've got dogginess. We've got one axis. And we love mixing mathematics with cute animals. And let's look at some more pictures. And yes, I have been assured the one in the bottom right is a dog. Yeah, I was assured by someone. So again, we can see they're cats and dogs, but not so big on the cuteness. I mean, if you like that sort of thing, hey, whatever floats your boat, you know? And we can put these on a graph as well. So now we've got two axes. We've got cattiness and dogginess and ah and ah. And time for a bit of terminology. So we got some definitions we can use. The axes we would call dimensions in data science, or at least what little data science I know. And we're going to call the points on the graph the embeddings. The graph is 2 dimensions, so we have 2 embeddings. And I look like Ultraman when I do that. I never realized. So yeah, we're going to call the whole thing the index, because why the hell not? So now, let's get a new image. And let's try to figure out where would this thing fit on the graph, this cute little fuzzy-wuzzy snowball. So, any takers? Top left, bottom right? Anyone?
Bottom right.
Bottom right, yes. I knew this audience participation thing would work. You know, we are really giving the Rocky Horror Show a run for their money here tonight, folks. So yes, it would fit on the bottom right, of course, with all the other cute puppies. We found the closest match, a match made in puppy dog heaven. So yeah, how did we do that? Well, we did it because we've been raised knowing what cats and dogs look like. We look at picture books as kids. We see cartoons. We see photos. We know what they sound like. We get cats and dogs. We grok the damn things. And that's pretty much how the deep learning models do it as well. They're fed a whole bunch of data, and then they're asked, with a new bunch of data, is this picture a cat or a dog? You get the answer right, you get a cookie. You get the answer wrong, you get a slap. And you go back and you to the next picture, and you improve and you learn and learn and learn again. Kind of like parenting a child, if you either want to give them diabetes or a slap. But isn't that just classification? Well, yes and no. Really, what we're doing with neural search is we're looking at the features. So we're not looking at, is it a cat or is it a dog? But we're looking at, does it have a wet nose? Does it have whiskers? Does it have pointy ears or droopy ears? All of these different kinds of things. And then we can compare groups of things. Well, we can compare things with other things based on features. So yeah, in a way, a neural network model is kind of just like your brain. In reality, it is a little more difficult. You know, I'm talking about wet noses, pointy or flappy ears. Often the dimensions a model uses, we don't really understand. They're black boxes, and there may be hundreds of them. So why give a damn? Because it's not just about fluffy animals. You can use this kind of similarity search in the medical field. You find someone with a weird lung condition, you can upload an X-ray of their lungs, find someone else who had the weird lung condition, find out what was wrong with them. Like I said, take pictures of your shoes, find similar shoes. Take pictures of the teapot your granny gave you before she died that you broke like an idiot, and you can find another one. So your dear old mother doesn't know the difference. Or things for online education as well. You can build a chatbot to make boring static courses more interactive, so you can learn more about the material. And all of these, we actually have examples, either running by different companies or just running on our own servers. And we're still pretty new. We're a startup that's under 2 years old. So I'll be honest, we don't have a lot of stuff running in the wild by big companies out there right now, but what we do have is pretty promising. You can search any kind of data as long as there's a machine learning model that can understand it. So you can search text in pretty much any language. There are loads of transformers models that can deal with English, Chinese, French, German, medical terms, even stuff like DNA, which when you think about it is just a string of text characters like GTAC. One of our community built a protein search engine, which is really cool. It has a Streamlit front end, and all the results come back as these rotating molecules. The problem is nobody knows how good the results are because none of us are molecular biologists. But it looks really cool, and it returns results. You can do image search, you can do audio, you can do video, which is basically just images and audio over time. 3D meshes is really cool as well, and I really hope we can get an example going. People are using that companies are using that in the wild, but I don't have anything I can show you. And you can combine these things as well. It's like when you go to Google Images and search using, I don't know, cute fluffy dog, you get pictures back of a cute fluffy dog, hopefully. That's text to image. And you can do that with what we're doing as well, with Jina. So text to image, image to text, audio to yada, 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 yada. You name it, any combination. Can you find true love? When somebody builds a model for it, maybe you can. And you can use hundreds of pre-existing models. Me, I'm not very clever. I don't know much data science or machine learning. So integrating an outside model, that's tricky for me. Writing my own model, that's really tricky. But we have a thing called Jina Hub, so you can just integrate all of this stuff with one line of code. The chatbot example, I showed a screenshot earlier, and the fashion search example, they're each under 100 lines of code. Because a lot of this stuff, you can just pull it instead of having to write it and integrate it yourself. You can also fine-tune it for your use case. Like if we take the clip model, that's really good for image to image or text to image or image to text. But it's just really generally good. So if you're searching chest x-rays or teapots or your favorite celebrities, it's going to be equally good at all of them and not great at anything. But you can fine-tune these models as well with another one of our things. So yeah, like I said, if you broke your granny's favorite teapot, I'm going to say we might be able to help, but it's a stretch. You'd have to put the work in, but it could be done. The advantages of all this is it's semantic. So if you're building Zalando 2.0 and you're searching for scarlet clothes or vermilion clothes or crimson clothes, it'll match that with red because it has a mental understanding that all of these things mean red. Without you having to actually implement a list of other words for red. It works with all disclaimer data types as long as there's a model and loads of plug-and-play modules. Traditionally, implementing this on your own, there's been a load of challenges because machine learning stuff, deep learning stuff is pretty cutting edge. You're using new versions of libraries, and they'll always clash with each other when you're trying to build something big. So yeah, we get around that and deploying it as well. We let you scale it up, replicas, sharding on Kubernetes, on Docker. It makes life a lot easier. And then you can run it on, AWS, Azure, whatever you like. So yeah, our mission, open source neural search ecosystem, allowing, you can read. Why am I still talking? These are meant to be hidden. So you only really need 3 concepts. It's dead basic. So you've got a document, that's a basic data type. It could be text, image, audio, video, whatever. It's all wrapped into one document. Anything that goes into Jina and comes out of Jina is a document or a list of an array of documents. You have an executor. An executor does one thing to a document. So let's say you want to search the collected works of Shakespeare. Well, it's going to be difficult if you'd want to break them down into sentences first, right? So that's what an executor would do. It could break all of Shakespeare down into different sentences for you to search. Or it could encode an image into something a deep neural network could understand. And then you want to combine these executors into a pipeline and scale it up. That's where a flow comes in. I'll skip the bash stuff. I don't know how we are on time. Never been good at it. How are we?
5 minutes.
Okay. How many people here use the command line? A lot? Oh, okay. Awesome. My people, my friends. So I think of Jina as really a lot like bash. And I live on the command line. I'm a terminal junkie, in a manner of speaking. That could sound very bad if you read it the wrong way. But if you're building a Jina flow, it's just flow.add.add.add.add. It's like piping stuff with bash. And because we have a lot of plug-and-play modules, it's kind of like apt-get as well. You can just use a new encoder. If clip isn't giving you good results, you could use big transfer encoder. Or if, I don't know, one of the transformers models for text isn't giving you good results, you could use a spaCy encoder instead. I personally go for spaCy. I find it much quicker, and I know the guys, so we have drinks. So I'm a little biased. We don't have time to go through the notebook, and I don't have it on this machine. But if you want to look at how to build a meme search engine, the URL is there. So yeah, in short, you can build a neural search engine with very few lines of code. As I said, most stuff that I've built under 100 lines. You can do it pretty much all on the cloud now as well. We're really rolling out the cloud features. Scale it up for deployment on Docker, Kubernetes, all the stuff you need for most use cases is just there. If you want to break images down, if you want to process PDFs, if you want to take every line of a CSV file and break that down into something you can search, if you want to take JSON, whatever, the modules are there for you to do the job. And the result, just an AI-powered search engine for any kind of unstructured data. And it's all open source. So yeah, you can go wild with it, do whatever you like. Do crazy stuff. We're doing stuff with DALL-E right now, which isn't really raison d'etre, but we're having fun with it and just mucking about in the office. So you can build any kind of weird pipeline you want to do whatever weird things you want. Yeah, if you want to learn more, well, talk to me afterwards. Let's have a beer. But you can also go to learn.jina.ai. And if you want to join our community, we're on Slack. That's the best way to talk to us. If you have questions, our engineers are really good at answering them. We don't bite much. We run quite a few events ourselves. So Engineering All Hands, those are all the fancy pants technical talks about all the cool new features, and we invite thought leaders to join us and talk about their cool machine learning stuff. Or our office hours, where you can join us online for a drink, talk about your use case, talk about issues you're facing using Jina, and our engineers will help sort you out. And yeah, if you want to follow me, my data's on the, I don't know which way to point, on the left, on the my left, on the your right, there. Cool. All right. Yeah, that's me. That's Jina. Thanks, everyone.
Any more questions, Alex? Can I ask a dumb question?
Oh, there's no such thing.
Might be.
Yeah, well.
How would you position yourself against something like Algolia?
That's a good question. I'd say we're completely open source, so you can do what you like with us. I haven't used Algolia much. If you want something out of the box, like there's an API, I'd say Algolia might be a better option.
Is one of them better for different type of data or something like that?
As I said, I haven't used Algolia much, but I would imagine Algolia is better for textual.
Yeah.
A lot of things can do text to text. And to be honest, that is when we surveyed our community, text search is one of the biggest things, either pure text or chatbots. I think that's just because that's how people imagine search. We're getting a lot of our community doing things like image search or multimodal, like text to image. Image to text, not so much, because even I can't see a use case for that. But we do have demos of image to text. So you can upload an image and find the line from Pride and Prejudice that matches it, which not a very useful use case.